Welcome to Puppetize Digital 2020. Whenever we do training courses, we see people struggling, not really with Puppet, but more with Git, and what kind of workflow should people use when they start working with Git. So this talk is about the Puppet control repository and several options for Git workflows. Look carefully which of the options might be a useful option for you. Who am I? My name is Martin. I'm using Puppet back since 2007. I'm doing the official Puppet trainings in Germany since 2011. I'm co-founder and CEO of Example 42. You might see some contributions either on our own supported or approved modules or even on Vox Populi modules. And during the trainings that I give in Germany, I usually get the same questions. How do we deal with Git? So what I want to cover in this talk is basically the Puppet control repository, giving a very short introduction onto what is the Puppet control repository. And then we directly move on to several Git workflows. So I will start with a simple one, which is the most simple to do, as the name mentioned. I will then proceed to, depending on your infrastructure, whether you need to stage stuff into some other Git servers. And last but least, I want to explain what is it that you have to do if you want to use Git Flow, what requirements does Git Flow has, and what is it that Git Flow brings to you in benefit over a simple Git workflow. So let's start with the Puppet control repository. The Puppet control repository is the one repository that you usually work with. So it's the one repo where you have your own code. You use the Puppet control repository also for adding upstream modules, library modules, how I used to call them, either by providing them in a Puppet file, mentioning which module in which version should be deployed, or even some companies do it via adding Git submodules. And the benefit of this control repository now is that you have a Git repository, and based on the branch names in this Git repository, you will receive Puppet environments. Puppet has a default environment called production. And this already confuses people. At least they might feel that they have an understanding, that they say, okay, now I got it. We have something like a production environment, we have something like a testing environment, and we have something like a development environment. So we should head into the procedure of having three branches in the control repository, one where we manage our development systems, one for the testing systems, and one for the production systems. That's a view that you usually say is some kind of stages. So it's a view from the application perspective, how the application is going forward from being developed into getting tested, into being brought into production and ready to use by customers. But Puppet is different. Puppet is describing your infrastructure. So when you're developing something, you want to have the possibility of testing things. So for sure, in your production environment, you want to have all systems connected to your Puppet production environment. What happens now if you do something like following the principle of development and development branch, testing and testing branch? We had one customer who was working in that way, saying in the development branch of the control repository, we manage the whole development infrastructure, including the virtualization. And I told them already, is this really a nice idea? And they said, yes, of course, that's the way how you develop code, how you do stuff. We're moving from development to testing into production. I asked them, what will happen if you do a commit that breaks the development system? Of course, they first said this will never happen. The development system is used by a customer. What kind of customer is using the development system? Well, fairly easy. All of your developers are working on the development system, so you have customers on that platform. What you don't have on the development system is some kind of intense monitoring and alerting, and maybe you don't have an SLA written down about availability of production environment. Well, at that specific customer, one day there was the day that had the name never, and one single commit broke the whole development platform. No more Git, no more Jira, no more Confluence, no more anything, because a single commit caused the virtualization platform to just tear down everything. Puppet did what it was expected to do. It was just that the commit was wrong and added wrong data to it. So this customer took him 3 days to build up the development platform again. 100 developers, 50 freelancers, 50 full-time employees were unable to work for 3 days. Afterwards, they learned we have several stages, but these stages are all things where we must ensure that these stages are running. So please consider that you have all your stages running against a Puppet production environment. Differences between the stages, like development system using another database server compared to testing, or development system has a newer version of an application compared to production, this is something that you can easily place into Jira. That's for it for the control repository. I don't want to dig further into what is it that you add to a control repository. I want to more concentrate on how you now bring changes in your control repository. And this is where I now come to Git Workflows, and I want to start with the most simple Git workflow. A simple Git workflow means that you're having one long-living protected branch. So nobody is allowed to push directly into your production branch. As I already mentioned, differences between the stages are added into Jira. And you can enable new features by adding feature flag parameters to your Puppet code, and can control also via Jira which feature should be used in which of your stage. So the production branch is now a protected branch. So how do you now bring changes into a protected branch? You can't directly push into that branch. That's something that you forbid on the Git server side. So all changes must come via feature branches. So you have your production branch, you're creating a feature branch, you add all of your code, and afterwards you do a merge request. If you want to test your feature branch, please take care to not have any special characters inside, like plus, minus, percentage, or slash, because usually branches with these characters will not get deployed by the Puppet Code Manager, for example. But you still can use them. And I want to show you how, by usually showing pictures. Pictures sometimes make things more clear compared to text. So on the top left-hand side, we have our default branch, usually production branch. We have 2 Puppet developers, person A, person B, and we have some Puppet trainees. Puppet trainees, they just check out an illegal Puppet environment name, branch name, by adding some pluses or minus signs inside. This is a playground branch, and it will never get deployed onto the master. It's there for coaching the people on giving them some topics to learn the Puppet thing. So the 2 Puppet developers are actively working on code changes. So developer A checks out a feature branch and starts coding. The same does developer B. Developer A is a little bit faster. Maybe it was less work to do, just change some Jira data. And developer A now puts a merge request and a review request from its own feature branch back into the default branch, usually production branch. When that review is done and the merge is accepted and merged back, developer B must update its own history by rebasing its own branch against the production branch. Afterwards, developer B can do the same and add a merge request and a review request. So 2 people working in parallel at the same, within the same Git control repository, maybe on different things. Maybe developer A is responsible for Windows, developer B is responsible for AIX system. Be sure these will never do, you will never do changes on the same files. If you do changes on the same files, you have to work with merge conflicts. That's something you should be aware when it comes to Git. So the easy thing, that is a way that is super easy to learn. It's super easy to handle. It's super easy to automate also the merge request creation and triggering people to do reviews by having some kind of a CI platform available. On the downside, you don't have real staging of code available. So you're always bring code into production via merge requests. So every node receives these changes. So you have to be sure that this change is only there where you want to have that change. Sometimes simple is not possible for several reasons. Consider something: you have different data centers spread amongst the world. You don't want to have dependencies on some internal systems, so you add Git servers and Puppet masters to all of your data centers. Or you have something like a network separation, where you say, we are working in a development network. This is an environment where we have more access, for example, via proxies to the internet. And we have the production network, which is a super tight, secure network. We have Git servers in our development network and in the production network. And now we must ensure that the code gets staged from development network into production network. So how do we do that? We have some requirements on that. The first thing is all code must be developed in development zone. In production, nobody is allowed to directly add code. You may only add code via merge requests. And what we usually do at customers, we establish a CI/CD system that synchronizes code using some kind of staging branch. Again, a picture for proper description. We are working always on the development branch. This is our long-living branch we are working on. We follow the simple Git workflow by having feature branches and do merge and review requests. When a feature branch is merged back into the default branch, development branch, a CI system will take care to merge this branch now into a staging branch. On every change that happens on a staging branch, a CI/CD system will pull the code from the left-hand side, which is my development network, and pushes it into the right-hand side, which is my production network. That's the only system which must have access in both networks. And it does not push the code into production. It again pushes the code into the same staging branch, but on the Git server in the production environment, production network. There you also again create a merge request, and this merge request must be done on the Git master in your production network. There someone has to log in and click the merge request. So the positive thing is something like separations regarding security is taken care of. Nobody is developing in the production network. All code is done outside. You have this intermediate staging branch to bring changes into your production network without automatically activating them. Activation must be done via merges. The downside is you need automation, so you need CI/CD. You need to understand how to call your Git server API and trigger actions on it. But the problem is that the merges that are done on the production side must be done in order. So what is when you have several different things to consider? Consider something an ITIL-based structure. So to say we have a change process, and maybe we have changes that get deployed faster, and we have changes that need more intense testing or more intense development. So they take longer. What is it if you have a strict separation between your development system and production systems required? What is it? Consider it that you have several systems in production, maybe with the same application, but security tells you the version that you deployed once This code base may never change. If you run a new version in production, you need a new code base. So you need a new branch, for example. How do you make hotfixes and features possible? And this is something where Git Flow comes and helps you and brings you some processes that you have to follow. There are several requirements that I say these are essential when working with Git Flow. The first one is never merge between branches. But that's the way how we usually bring changes inside. How else should we do this? Let's wait for a moment. I will explain it. The next thing is each branch is an individual development, see it like an individual Git repository. It's not a Git repository individually, but it's branch inside the same, but keep them separated. And if you want to have changes, you have to learn about cherry picking changes from stage to stage. Back to the questions, why no merges between branches? When you do merges between branches, you're saying you have the history that you merge into the next branch. So consider the following situation. You have your development branch. You have two feature branches, feature A and feature B. Feature A is, again, easy to use, easy to develop. So you're bringing this branch into your development branch, merge it back. I suppose there's one arrow missing from the development plus A button back to feature branch B, because feature B now needs to rebase. I forgot to add that arrow. So feature B now consists of the status of the development branch plus the feature from the feature A branch. And now you add the next feature, feature B. And now feature A we learn that feature A is incomplete, that it has some things missing, that it does things on too many systems, which it shouldn't do. So people have to still continue working on this feature A, but feature B is something that you want to have in production. But when you now merge from your development plus A plus B into production, you get both features inside, but you only want feature B in production. That's the reason why you cannot do merges anymore. Instead, I'd like to show another picture and saying we have several long-living branches: development, testing, production, version 1, version 1.5, version 2. It's just long-living branches. On every branch, you do a feature branch and add your changes to the feature branch and merge it back. Sounds totally crazy, because you have to do all of your work 3 times. You have to do it on the development branch, you have to do it on the testing branch, and you have to do it on the production branch. Git can help you to limit this effort and this work. There is some more requirements to do what we want to do, and this covers the feature branches. Feature branches should or may consist of a single commit only. But we can have multiple commits on a feature branch, yes. But if you afterwards merge them and you have merge conflicts, you have to solve the merge conflicts for each of your commits. If you either squash your commits or using git commit -- amend instead of just git commit, then you don't have multiple commits, you have a single commit, and this single commit gets merged into your branch. So what we already learned is Git Flow has some hard requirements on learning Git and knowing about several Git things, like squashing, like rebasing, and solving merge conflicts. And now we add one more Git topic on top by saying, when we develop something in the development branch, we do a feature branch on development, and we merge it back. We can then reuse what we did here and cherry pick that change into a testing feature branch. As you can see, the arrows between the feature branches both go in both directions. So following this principle, you have the possibility of bringing hotfixes into production, cherry pick them into testing and into development, or bringing fixes into testing, cherry picking them back into development, and later on cherry picking them also in production. You need a tight follow-up on which change is in which state. You need a ticketing system to follow up whether a work is done completely. The work is not done for the hotfix when you've brought the hotfix into production. The work is done when that hotfix is deployed in production and available in testing and available in development. So the positive thing is you can have branch-specific development, each long-living branch. On the other hand, you need to have a good understanding on Git, squashing, rebasing, cherry picking. And it's a little bit of more work to bring changes into a desired branch because you have to work on multiple branches. I really like that quote. I don't know which day or year it was that Steve Jobs mentioned it, but Steve made it very clear that he said, simple is harder than complex. Sounds weird, but let's dig into it by saying, when you have something complex or hard, then it's hard for you to make it as simple as possible. So having a complex workflow, tear it down into most simple to understand single steps. I like it also that he said, in the end, when you've done it right and you've made your complex thing simple, you definitely can move mountains, you can move faster, you can deploy better, you can deploy more secure. So, starting with Git, doing Git workflows, doing decisions on Git workflows. Do yourself a favor and start simple and expand when you learn more about Git. Follow the KISS principle. Keep it stupid simple. Don't do complex things when you don't need them. We are fans of automation, otherwise we wouldn't use Puppet. So also take care on automation of your code deployment. Get yourself a CI/CD system that does all the manual steps for you because they are just repetitive patterns that occur on day by day. Git has a learning curve. We see this in every training when we usually start with the people and describing Git add, Git commit, Git push. Mostly they forget about the Git push afterwards. They learn it when their code doesn't change. So please take care and learn Git. And if you don't need them, you don't have to adopt complex workflows. I see people that made a decision on a super complex Git workflow, and in the end, people were super frustrated of that complex workflow. And afterwards, they learned this complex workflow wasn't even required or necessary. They could have used a far more simple workflow. And as we are living in super special times, please stop social distancing. You need physical distance, not social distance. Keep the people physically off, but keep them in your heart and your brain. Take care on people and on small businesses who need your help. Thank you.